Hello there, welcome to the Learning of Engineering tutorials. In this video lecture, we are talking about the kinematic links. So what is the kinematic link and how it helps to build emissions or result the mechanisms. So here the kinematic links, and we will try to see some of the examples where we are using actually. As a human being, we are always trying to reduce the human effort to complete any task. In this process, we have developed one of the model is the IC engines. So in this case, we can see there the number of links are there at the same time. So they had a relative motions among themselves. Some are going to be rigid, some are the flexible in nature. There we can see here is the lathe machine. The lathe machine also have different types of relative motions we are able to generate. That means a constrained motion it is generating to fulfill the desired functions. And similarly here is the aeroplane engines we are using, and it is also the one example of the kinematic links. It's a combination of the kinematic links, there we can see it. And here is the robo arm. So robo arm is going to be also, it's going to be trying to mimic the human the nature. And here is the rocket engine also, it's one of the part of the kinematic links. So then exactly what is the kinematic links here? There we can see it is a fundamental building block for the construction of any mechanisms or to the machines. The mechanism is when we are going to be delivered the constrained motion to the combination of the links, we are going to be say the mechanism. The combination of the mechanisms are going to be calling the machines. Now we can see here the definition of the kinematic links. What is the kinematic link definitions? So as we know, it is a rigid body or a resistance body or combination of the resistance bodies. If they connected, there is no relative motion. But when it is assembled to the another element, it should have to maintain the relative motions. I hope you are able to understand here the minimum, the definitions of the kinematic links. It's a kinematic body is the rigid body or maybe the resistance body or maybe the combination of the resistance bodies. When this combination of the resistance bodies are connected, there is no relative motion. But when it is connected to the another link, there is going to be a relative motion and have to maintain. So we'll try to see what is exactly the rigid body and what is the resistance body and what is the assembly of the resistance bodies and how it is going to be generating the relative motions. In these slides we can see what is a rigid body. So rigid body, as we have a definition of that, it cannot deform. Even the material is started to deform, but it is not disturbing any kind of the final function of the system, then it is going to be negligible. It means that the shape and size remains at the same position. It's not regain its original position even after you apply the some load. So that means it is going to be a rigid body. These links do not deform significantly during the motion and maintaining their shape and size. So automatically it's going to be fulfilling the example of that. So including the metal rods and gears are the examples for the rigid bodies. There we can see here. So here is going to be a rigid bodies, the combination of the rigid bodies, there we can see it here. So here the gas turbine engines we are going to be see how the fluids are going to be forming. The next one is the aeroplane structures, also we can see it is going to be a rigid body. But in this case also there is a deformation is there, but it can regain its shape and size without any ambiguity. And here also one more example is the car, the body. So it was prepared with the different types of the metals. Some is going to be they are going to be load absorbing links, some are load transmitting, some load is going to be dissipating purpose they are going to be designed, so that the crash test is going to be in a well manner. So what is the resistance body? The resistance body is nothing but a flexible body. These links undergo slight deformation while transmitting motion, but it does not affect the overall function. It means that when the rigid body is never go to the deformation, but in the resistance body they undergo the deformation, but it not affect the final function of the system. For examples are the belts and the chains. So here there we can see the chain mechanism is going to be running here. So here is the chain system is there. It's a combination of the different flexible links, the rigid links, but when they are going to be connected, it will become more flexible. It means it is transmitting the power from source to the destination. So that this is the one example. There we can see here the IC engines, the belt drives they are going to be using to transmit the power. So these are the resistance bodies. It means it cannot affect the final function of the system. So there, what is the resistance body? Again, we are going to be talking here. The fluid link also comes under the resistance body. These links use fluid to transmit the motion as well as the force. So for examples, include hydraulic cylinders and torque converters. We are going to be using examples. There we can see in this JCB. So there we are going to be using the hydraulic cylinders to transmit and to operate the link of this one, and they are going to be using the different types of the hydraulic cylinders, and fluid is activating in the forward directions, and accordingly it's lifting the soil and it's taking to the next. So the next one is going to be, here is the torque converters. There we can see the cement mixing, the lorry we are going to be using here, where it will going to be converting the high power into a rotating motion over here. So what is the resistance body? In this case also we can say this is also the floating links, which is not connected to any of the part of the system. These are not connected to the ground or any fixed reference point, allowing for more complex movements. So here, for example, including a robot end actuators and linkage in a suspension system. As for my knowledge point of view, I am going to be say this is also the floating link, which is not connected to the ground, but it is performing its exactly what purpose we design. And here is also another floating link we are going to be see that we are using to extract the minerals or the oils specifically from the underground of the water. So there we can see is the end effect actuators. We are going to be see the robots are doing all these jobs. So application of the kinematic links, where we can use these kind of the applications. So here we can use for the robotics. Links form the arms, manipulators of the robots, enabling them to perform diverse tasks. So this kind of applications nowadays we can see very widely in the military applications. And the missions lights are essential components in missions like engines, transmissions and the pumps. So these are all the combination of the rigid bodies as well as the resistance bodies. And the next one is the instruments. There we can see to measure the different types of the pressure levels, temperatures and volumes. There we can see different units on the speed of the systems. These are going to be very widely using. The automobiles also, there we can see the crucial in vehicle suspension system, steering mechanisms and other the parts of the system. There we can see, and we have seen the kinematic links are the fundamental building blocks for the missions as well as the mechanisms. They provide the basic structure for transmitting the motion as well as the force. Understanding the different types of application of the kinematic link is essential for various engineering disciplines. There we can see here we have defined what is the kinematic link, and we try to understand the definition in terms of the rigid body, the resistance body or the combination of the resistance bodies when they are going to be assembled, how the relative motion is going to be connecting to each other. So thank you. If you feel any difficulty, so please put in the comment section so that I can reach you out. Thank you.